Hi viewers, according to the recent data collected through James Webb Telescope, there are four types of exoplanets. And before we discuss what are these four kind of exoplanets are, it is better to know how James Webb finds exoplanets. Actually, James Webb cannot directly observe the exoplanets or directly see the exoplanets to collect the data. It is because of the greatest brightness of the parent star. So it used the revolutionary transit method. You know, the transit method is when the exoplanet passes through the parent star. The exoplanet always rotates the or moves the parent star when it comes in front of the star. It means the viewpoint of the telescope, such as James Webb, it blocks a small amount of the light of that parent star. James Webb can exactly calculate how much of the light is blocked by the exoplanet, and using that data the James Webb can say the size of the exoplanet. This is the first method. Alternatively, when that particular exoplanet keep on moving its parent star, it goes behind the viewpoint of the telescope. It means the other side of the star, where secondary eclipse occur. The secondary eclipse mean the star blocks the light of the total light of the planet. Since the star is much bigger than the planet, star can block total light of the planet. Then there is a composition of that or transmission of the spectroscopy occurs. Transmission of the spectroscopy mean the mixer of the light. The mixer of the light of the particular star as well as the exoplanet. When these lights are mixed, what kind of molecules or atoms are missing could be determined by the telescope. So, using the transmission spectroscopy method, James Webb can tell what kind of atoms and what kind of molecules are missing, and what kind of atoms and what kind of molecules are present in the atmosphere of the particular exoplanet. Whether there is a atmosphere is there, it will determine first of all whether there is a atmosphere. If there is a atmosphere, what kind of atoms are there and molecules are there, what molecules are missing, what molecules are present. All these data could be exactly calculated by James Webb Telescope's modern technology. This is how the James Webb calculate and finds and categorize the four categories of types of exoplanets. Accordingly, the first type of exoplanet are called our Jupiter-like exoplanets because of their size. Some of these exoplanets are larger than Jupiter. At least they are the size of the Jupiter. At least they are Jupiter's size or larger than Jupiter's. Some of these exoplanets are much closer to their parent star, so they are called hot Jupiter. Such an exoplanet is recently found by James Webb, that is called WASP-17b. WASP-17b is a hot Jupiter. It is a large planet like a Jupiter. It is a gas giant. This planet is totally made by the hydrogen and helium like our Jupiter, but it is much hotter than our Jupiter. So this kind of Jovian or larger planets are having very thinner core, very small core, but very large atmosphere, very large amount of gases of especially hydrogen and helium. This is the first category where we cannot expect life much and more. The second category of planets are called Neptune-like or Sub-Neptunian planets. These kind of planets are like our Neptune or smaller, little bit smaller than our Neptune. Most of the Sub-Neptunian planets found are nothing like in our solar system, because there is no planet that is little bit smaller than Neptune. These kind of planets, Neptune sized or sub-Neptunian sized planets, are mostly made by, like a Jovian planets, mostly made by the gases, especially hydrogen and helium, and some ammonia, methane also present. But these atmosphere are much thicker than the previous Jovian planets or Jupiter sized planets. Atmosphere are not thicker, not much thicker, but the Neptune size, the second category planets, atmosphere is much thicker. Then they have much larger core also when compared to the Jovian or Jupiter sized planet. These second types of planets have much larger core. Very good example for this planet is recently found K218b. K218b is a sub-Neptunian planet. This planet is called to be Haitian planet sometime. The Haitian planet means the planet that is totally covered like by a ocean. If any planet is totally covered by the ocean, it is called the Haitian planet. So very good example of sub-Neptunian or second category of planet is K218b, founded by James Webb. Now we will move to the third category. The third category of planets are called super Earths. It means these planets are larger than Earth but smaller than Neptune. Most of these planets are 2 to 3 times larger than our Earth. But most of these planets are made by rocks like our Earth, as well as they have much and more gases also. They have methane, ammonia and carbon oxide gases. Mostly they have methane, ammonia and carbon oxide gases. Also these planets also contain hydrogen and helium gases. So these super Earth planets are less likely to search for life because of their larger size. Even though they are rocky, they have totally different feature than our Earth. Very good example is GJ486. The recently found GJ486 is the very good example for super Earth planets. These kind of planets, some of these kind of planets may be Haitian planets. It means, as we said before, they are totally covered by oceans. In some of these planets, water vapor also detected, but it is not concluded whether the water vapor is coming from the planets or from the star. The last and fourth and most important category is Earth-sized rocky planets. The last one is rocky planets. They are almost size of like our Earth or smaller than our Earth. The very good example is the TRAPPIST system. TRAPPIST is a red dwarf star that has 8 planets like our Earth. These 8 planets are totally rocky, almost like our Earth, almost our size of their size also like our Earth. So much of the researches are going on these kind of planets because there are chances for the search for life. There are 8 planets we said. They have given the name B, C, D, E, F, G. Likewise, in the E planet, the TRAPPIST E planet is located exactly the good locations that is called habitable, where the water can exist as a liquid. So the life expectancy, the expecting for life in this planet and other planet in the TRAPPIST system is high in chances. Researchers also conducting much and more researches in this regard. So the fourth and final and most important type of the planet that is categorized according to the James Webb's finding is Earth-like rocky planets. In this video we have brought you the knowledge about the 4 types of planets categorized according to recent data of James Webb and how James Webb finds these planets. Please be joined with us for this kind of easier and much important astronomical data in English.